Hello, everyone. Welcome to CISO Platform, the world's leading online community dedicated to information security executives, including CISOs, CIOs, CSOs, CTOs, and directors, with over 40,000 global community members. Today, we are excited to have Jitendra Chauhan, Head of Research at FireCompass, joining us. In this webinar, Jitendra will deep dive into 6 most critical and ransomware weaponized CVEs published in the last 3 months. He will further share how CISOs can identify them and immediately decrease the chance of ransomware by 26%. Thank you for joining us, and let's get started. Over to you, Jitendra.
Thank you, Nazia. Thank you, and welcome all. Let's get started. So today we have a very interesting topic, which I feel very excited to share, and it is about reducing ransomware risk by 26% by fixing, CVEs. Now, before we, go to the solution, let's discuss this problem of ransomwares. Of course, it is not new, but I want to highlight some of the stats which Verizon, DBIR, and IBM X-Force reports have shared for the last few years. And one of the interesting insight that comes from Verizon DBIR report is that ransomwares are on rise 20% year on year from the last, I think at least 5 years now, which means that every 3 years, the number of incidents of ransomwares will kind of double. That is a magic number of this 20%. And for how long it's going to happen, no one knows, but definitely it's on the rise, and it's going to be increasing for a few more years at least. Not only that, we have also seen that the mean time to remediate a critical vulnerability has reduced from weeks or months to few days. And the reason for this is that ransomwares and attackers are increasingly using automation and AI to identify these vulnerabilities in your attack surface. We will come to that in a while, that how do they do it, but this is a very important point in order to make any strategy now in this new era. And very interesting thing is this, that although we have security practices to find all possible bugs and vulnerabilities, such as business logic vulnerabilities in web apps, and mitigating all the info level vulnerabilities, medium vulnerabilities, interestingly, ransomwares target 1% of NVD high and critical CVEs. So just 1% of them are being targeted by attackers to achieve this mega result. Now I'll just give you some numbers that the number of critical high CVEs currently as of today are around 50,000. So I'm just talking about CVEs greater than probably 6 or 7 CVSS score, right, in order to consider as high, and 7 probably 7 and above, and then this I'm also referring to the CISA prioritized CVEs. CISA maintains a list of CVEs which are being targeted by ransomwares, and they make a news and they get an alert from various threat intel feeds, and they have around 500 critical CVEs in their list. So the figure comes out to be 1%, which means 1% of those high and critical CVEs which are there in your NVD database are currently being targeted by ransomwares. Now, I'm sure everyone knows how ransomware works, that ransomwares most of the time start externally. So they are no way closer physically to your organization. They are somewhere sitting in different countries. It can be any other country, any country, you know, right? And one of their primary way to attack an organization is to get an initial foothold, right? When they will get some access to your servers using either exploitation or, you know, various other techniques. And once this initial foothold is done, then the snowball gets start rolling, right? And it's very difficult to, you know, stop this snowball once the ransomwares are in your network, and it starts spreading. You know, then it becomes a different game altogether. So let's, you know, see what are the weaknesses, top 3 weaknesses that leads, you know, that helps ransomware to get the initial foothold. And the good insight come from IBM, you know, and both Verizon reports. You know, as per IBM X-Force report, you know, 80% of 3 weaknesses leads to 80% of ransomwares, and these 3 weaknesses are exploiting external CVEs, and this leads to 26% of attacks. It basically contributes to 26% of cases where ransomware gets initial foothold into the organization. Then you know, of course, the most prominent one is the phishing, where you know, attackers usually send a phishing email on a mass scale, or a, you know, spear phishing, and with malicious attachment, link, and allow users, and various other, you know, techniques, which including even social media wishing, which allow user to ultimately give access to this to the malwares and ransomwares on their systems, and from there, you know, the attack starts, right? Apart from that, 60% of the cases are because of shadow IT, which means the assets which are not probably are there or not there in the asset inventory, but are left open for the attackers on the public internet. So just give you a number in terms of CVEs. We have seen 49 CVEs being added to the CISA, you know, database from the last few months, which have been targeted by ransomwares in just 2023, and 366 CVs were added in 2022, which were, you know, targeted by ransomwares. And this trend will continue, of course, with the end of 2023. A lot of other CVs will probably also make it into CISA, you know, knowledge base of vulnerabilities. In shadow IT, I think one of the most prominent vector is using stolen credentials in desktop sharing software such as RDP, VPN, AnyConnect. Now, with the advent of remote working, when the workforce is all around the globe, the incidents of using stolen credentials and get access to the, you know, network and to some of the systems has increased drastically. This is because, you know, the collaboration is right now not limited to within the perimeter of the network. So as a result, you know, using the stolen credentials. Now, where are the stolen credentials coming from? These are coming from, you know, various attack and breach databases, which were, you know, published for the last maybe, you know, 5 to 10 years, where billions and billions of, you know, credentials are available on dark web, and many of them are being reused by employees, you know, intentionally, non-intentionally, on other, you know, systems, which probably works in the enterprise. And not only that, some of the cases of shadow IT, a lot of cases in shadow IT also comes from, you know, code leaks. Like the developers, when they write open source tools, they leave credentials and API keys in the code and make it and publish it on the developer, or they can also leave these credentials in the build, in the software build, such as Jenkins or maybe Circle CI or maybe other any other CI/CD platform, right? So in one of the incidents which has happened last 1 month back, where after doing phishing, once the attacker got access to one of the systems, one of the DevOps systems, and then they got access to their CI/CD system, what they have found out is they decompiled the build, and then in the build itself there were a package of credentials being packaged together with the build, and as a result they got access to a lot of other systems all around inside the enterprise network. Yeah, along with credentials, another lot of cases being reported where the leaked API keys, where the API keys are also being published in the code that attackers can get access. For the past few years, there has been a lot of incidents because the databases such as MongoDB, Elasticsearch being open, Kubernetes. We in FireCompass we did a research last year where we tracked all the all the Kubernetes instances, hundreds and hundreds of Kubernetes instances being left open because of a bug in one of the open source library, and because of which we got access to their Kubernetes cluster, and we reported this to various organizations and they could fix it immediately. Not only that, we have also seen attackers using Docker instances which are left open to the internet because of certain misconfigurations. So shadow IT, assets which are exposed to the internet with a misconfiguration, with some kind of misconfiguration, the code which is being leaked, contributes to at least 60% of cases where the attackers can get access to initial foothold into the organization. All right, let's now, not only that, attackers have now the capability to scan internet in just few days, and that makes it increasingly difficult to that makes the life of a defender increasingly difficult. The reason being that if attacker can scan the internet in few days, which means your mean time to remediate has drastically decreased from weeks to days, in fact. Now, how does this automation works? I'll just describe in few words and sentences, and I'll try to simplify this. By the way, this is and when very simplified version of what happens in reality. Now, one of the first step that the attackers do is to create an internet-wide scanner. Now, there are various open source tools available, which, if configured properly using an expert, can be used to scan the whole internet actually within few days. And if you put more horsepower, more computing resources, within hours, in fact. Now, this is not an easy task, by the way, right? There are 3 billion IPv4 addresses, and there are 65,000 ports, which makes it nearly impossible, right, to scan the whole internet. But then the advantage the attacker has is that they do not scan whole internet on all the ports, but they do it as per the attack. Say a vulnerability which is being there on a specific framework, such as ESXi, VMware, which are exposed outside, then they have to just scan certain ports, only I think few port on all the IPs, right? And that makes it relatively easier task for them. Okay, and in fact, actually, what attackers do nowadays is that they maintain this database, pre-indexed. They keep on crawling and can maintain this database, and in some raw big data tables, big data, solutions, so that, whenever a vulnerability comes up, they can go and just do a search on this and find a potential target, right? So first step is internet-wide scan and index it into the database so that you can search later. Then the next step is to use a deep crawler. Now, what this crawler does actually is for different products. It goes and crawl and do a fingerprinting of the service. The reason, and then detect, technology, its versions, etc. The reason for this is it makes easy to map a CVE to a technology to a target. Right? For example, if again ESXi server, if I take, I can go and scan the IPs. I can grab the banners. I can do fingerprinting that this specific technology, which is VMware, a specific version. I can write parser to extract the versions and the technology on it, and I can keep it indexed actually, or even we can use it as on demand. In fact, whenever vulnerability comes, we can go and scan the internet, scan the IPs. So once this crawling is done, the next step is CVE identification, which means that once a vulnerability is vulnerability is published, it's matter of within maybe a few minutes to find out or maybe an hour to find out what versions are really impacted, which technology is really impacted. And once it is identified, we can make a query into this database to find out which all targets are potentially vulnerable, right? And once this vulnerability identification is done on these potential targets, the next step is to try out the exploits. And generally, these exploits, once run, as I said, the vulnerabilities are those specific vulnerabilities which can give remote code execution most of the time to the attacker. And these are the vulnerabilities which are being targeted by ransomwares. So this is the the flow that automation that has allowed attackers to automate this whole mass scale scanning and attacking within few days, in fact, and which actually the point that I was referring to, that the mean time to remediate a vulnerability has reduced to even few days. Now, in summary, mitigating external critical CVEs could reduce ransomwares by 26%, I think, right? As per the stats, as per the the research by various reports, right? But the catch is that your MTTR has to be few days. If it is not done, if the vulnerability is left open more than few days, then there is an increasing chance that it can be potential target of an attacker. And it is just luck that it is not being exploited. But then, if it is done correctly and there is a practice that continuously, have these vulnerabilities and mitigate them on within few days, then yes, we can actually reduce the ransomware risk by 26%. Now the question is how. Now, before going to details on how, I just want to talk about FireCompass. So FireCompass Research Team, and I want to just give a background about ourselves. FireCompass Research Team, by the way, track brand new latest CVEs on continuous basis. Like whenever a new vulnerability is added to the NVD database, we go and track it, we go and analyze it. And then we help our customers to identify exposure to these CVEs within a day, so that customers can take action and mitigate risk of these CVEs using appropriate security measures. Now we have prioritized the upcoming, we will talk about certain CVEs, and then we have sent in alerts, exposure alerts to our customers that will reduce the risk ransomware at least by 26%, assuming you have already fixed critical historical other critical CVEs. So assuming that other CVEs which are already being fixed, the new CVEs that we will discuss right now, if those are fixed, then your chance of risk of ransomware will be reduced by 26%. Now let me talk about some of the CVEs and which ransomwares and are targeting them. Now ransomware runs on GAS, Global Attack Surface. Yeah, that's a catchphrase. And then, so as I mentioned before, ransomwares go and target various in scale, run scan on internet wide and find potential target. So one of the CVE which we studied is CVE 2023, which is in FOTA Go Anywhere command injection. And this CVE is being targeted by increasingly being targeted by clock ransomware, which is a Russian origin ransomware targeting worldwide organizations. And although it uses various attack vectors such as phishing, but then in this case recently they have also utilized this CVE to target organizations and get initial foothold. Now, why this CV has been targeted by this ransomware? The reason being that it has a global attack surface presence. I mean, just doing a search on few Shodan or other internet search engines, you can get a exposure of this CVE on the, like in US, the exposure of the CV is like at least 897 targets are right now available with a strict search queries. I mean, right, with after filtering out even the honeypots, and other noise, we figured out that at least 897 FOTA Go Anywhere software is being exposed outside just in the United States. And as these are exposed outside, as you can see that it is, and if they are, and this is the latest CV by the way, and as the CV is released, if those softwares are not patched within few days, as I said, then they have a risk of being exploited by cloud ransomwares. Now, just talking about bit about this vulnerability, now, if you just look at this vulnerability, it is a command injection vulnerability, which means it is remotely exploitable and using a HTTP payload. So what attacker need to do is craft a HTTP based exploit, not like RDP, buffer overflow. Very simple, easy. Probably is one of the easier exploit to target, to launch, and once launched, so the FOTA Go Anywhere has a vulnerability where it accepts, in one of the parameter, you can inject some of the commands which allow attacker to run those commands on the instance where the software is running. And as a result, the the attacker can actually run their own commands on the system and can get a shell back to this command and control center. And this is how one of these vulnerability got exploited. Yep. Now, if you have this FOTA Go Anywhere, of course, exposure outside, first of all, we need to identify, and if it has, then it need to be fixed right away. Now, apart from this, now next vulnerability which we prioritize based on our research is the vulnerability in ZK framework. It is a Java framework which is used in many softwares, and one of the, now this vulnerability actually is not a new vulnerability, 2023, but this has been weaponized by Logbit very recently. And as I said, how ransomwares go and use a old vulnerability to target right now is because they are scanning the whole internet and they are constantly looking for global attack surface presence of a vulnerability, right? Probably initially they didn't prioritize it, but then as they are like around 50,000 NVD vulnerabilities are there, but their attack surface may not be large, may not be a significant value, a significant size, right? So there are various factors that comes into picture when the ransomwares should use these factors to target, to prioritize a vulnerability, and one of them probably is having a global attack surface present, which means it should have a significant presence on a global scale. Second, probably is easy to exploit. The vulnerability should be easy to exploit, should bypass various security controls, like sending a HTTP request probably is one of the way to bypass a lot of security controls, because HTTP is being used very generically all around. So as I said, the ZK framework, which is a Java framework, and this vulnerability works very similar to Log4j, in fact, right? So in this vulnerability, the user can send again another packet, another HTTP request to the server, respect server, and then it actually go and disclose information related to sensitive files on the local instance, which may include even credentials. And as a result, Logbit could actually use those credentials to gain access to the system. And this, as you can see, that it has the in United States itself, with conservative queries written, restricted queries written, there are around 1,000 instances currently being exposed just in United States right now. Now, another interesting vulnerability, which is, I think, is not a new one, but being highlighted, being exploited recently because of its global attack surface presence, such as 6,666 servers at least are available online, is a VMware A6i server vulnerability, which is exposed outside. And this is a heap overflow vulnerability, and this is one of the, compared to the last two, this is a little bit complex to exploit, but then this is also a bit reliable, and then it has a higher global attack surface, which makes it very interesting, very lucrative for various ransomwares to utilize this vulnerability to get initial foothold. Yeah. Now, next vulnerability which is in the list is in the Microsoft Exchange server. Again, not a new vulnerability, but being weaponized very recently by a ransomware group called Hive. And I can see that Hive is making news recently for for utilizing this Microsoft Exchange servers. Now, why Microsoft Exchange servers? As you can see that it is global attack surface is again very large, because it's a very popular software, and there are a lot of local and legacy installations still available around the globe. Probably organizations still have not migrated to Office 365, but then they are still using their own version of Microsoft Exchange servers. As a result, there is a remote code execution vulnerability which was published in 2021, which is being utilized by Hive ransomware to get initial foothold, and this has a huge attack surface. Another one is CVE 2021, which is vulnerability is BOA file server, and its attack surface is also extremely large. This is a pretty common open source HTTP server used for file storing and exchanging files. And one of the vulnerability here again is which can allow attacker to read sensitive information on the local file itself, which include credentials, of course. And as a result, it is easy to exploit, having large attack surface, lot of potential targets, can be exploited on a mass scale, and therefore it is being prioritized by attackers. Out of all of these 5, I think the next vulnerability which I'm going to talk about is in the, it's not does not have probably external attack surface, because this is an internal facing vulnerability, and this is pretty common. Windows smart screen security feature, which is most of the organizations have smart screens. I mean, users enable smart screens. And what this ransomware does is that it first sends a phishing email to the users, and once the user click the phishing email, gets installed the first installer, the malware, the ransomware uses this vulnerability then to spread all around. Now, as you can see that the vulnerability does not have, this vulnerability does not have external attack surface, but it has a huge internal attack surface. It can, depends on the, of course, the whether this feature is enabled or not, but it can have a huge attack surface. And as a result, this once the phishing is completed, successful, uh, this ransomware can actually go and spread internally. Yep. So these are the 6, CVEs that we prioritized based on the threat actors very recently, and why they are, have a global impact. And as you can see that all of them has few things in common. Number one, they all have a global attack surface presence, right? And they are easy to exploit, not very complex to write exploits. And these CVEs can be easy to exploit, and utilize, a lot of them utilize just vulnerabilities in very popular standard softwares, which can be exploited remotely, and which can lead to RCE, remote code execution. Along with these vulnerabilities, I think there are other vulnerabilities which are also being targeted by various ransomwares, such as 3CX supply chain. So 3CX basically is it's a supply chain attack where the user has been tricked to download a malicious, the changed version of 3CX software from a malicious location, using various techniques such as DNS redirection, or hijacking the original source of from where the user can download software, or even with phishing, with a link where user are prompted to download the upgrade, and they click on it, and then they get the malicious, malicious upgrade. I think we have already covered ZK and FOTA Go Anywhere. Another interesting vulnerability is in Apache Spark UI, and very popular, 40 OS path traversal RCE, TP link router, which also has a huge attack surface, and IBM Aspera, software from IBM, which have been targeted by ransomwares. Now, Apache Spark UI, I think this is a very interesting one. Apache Spark, as you know, that is being used by organizations to do big data processing, and it has a management interface which is exposed outside, which can be exposed outside for remote work, manageability, etc. Now, what has happened is that it has a vulnerability which does not require authentication, by the way, right? And where you can go and inject a command that can run on the instance of the management console, and as a result, it leads to the remote code execution. Similar, vulnerability was another vulnerability which I want to highlight is 40 OS path, which is in Fortinet, firewalls which are exposed outside, which has a path traversal vulnerability, and its exploit is available online, being exploited in the wild for a while now. and it has a large attack surface again because it is a firewall exposed. It has to be exposed outside, and the vulnerability, what it does, it goes and read the file location from a certain place, which can also lead to, in certain cases, it can also allow attacker to go and place a file at a specific place, and as a result it can lead to remote code execution, which is again very dangerous because it is on the edge. Yep. So some of these vulnerabilities and many more actually being prioritized by us, by FireCompass Research Team, and that and we have sent these alerts to our customers so that they can act on it. Now, all of these vulnerabilities have three things in common. Number one, they're remotely exploitable. Their exploits most of the time are easy to write and easy to trigger. They have a global attack surface. They have enough gas, in fact, to trigger, which we have seen, like, for all of these vulnerabilities have significant attack surface, available online. And then third one is they lead to RCE, remote code execution, because that's what ransomware want. Ransomware needs initial foothold into your organization. If they're not targeting phishing, they need an RCE into the organization. Sometimes the RCE can happen even without exploit, as I said, in shadow IT or cases where the Kubernetes case, we discussed that it has Kubernetes or a Docker, APIs exposed online to the internet without any authentication, and that was one of the attack vectors ransomware can use. And similarly, the MongoDB servers or Elasticsearch exposed outside without any authentication can also be used by ransomwares. So most of us already have our practices in place, such as VM, pen test, red teaming. So what's next? What is to be required? Now, one of the challenge which I see, with the practices such as pen test and red teaming is that they are done quarterly, or in a lot of cases, half yearly or even 1 year. Like I've done red teaming for various organizations, and many times, we have to travel to the respective location, and we could just do twice in a year because that was the budget of an organization. They cannot make us sit there forever. It's not possible. So most of the time, red teaming and pen testing is done quarterly, but the vulnerabilities which we discuss can arise, anytime, any day, right? Like we are discussing today, and tomorrow a critical vulnerability can appear, right? So that is one challenge with the existing, red teaming and pen testing, practice which I have seen. Now, definitely we have a vulnerability assessment practice in place. We scan our network on a continuous basis, on a regular basis, at least, in some cases on a weekly basis. And we have also seen it extreme, where some organizations also scan their whole attack surface on a daily basis. Of course, this becomes challenging if you have a huge attack surface. Like for some organizations, we have seen thousands and even millions of IPs. Not easy to, not viable to scan on daily basis. But the challenge is different. The challenge is that VA generally generate a lot of noise, and we all know this, that VA generate a lot of noise in terms of lot of vulnerabilities to fix and so on. And as a result, as the ransomware target only 1% of vulnerabilities, but we end up in managing more than vulnerabilities which are being targeted by ransomwares. So that is the next challenge which I see in the current practice. Third, challenge which I see is dynamic attack surface. So many of the organizations has a dynamic attack surface, which means their IP is constantly getting changed on regular basis. Either they have been added, or they are replaced, the IP is being replaced by another IP, and so on. And this is happening because of the cloud adoption. As a result, pen test and red team, when we conduct pen test and red team, we need to first enumerate their attack surface because it is constantly changing. As a result, whatever we have pen tested before, the IPs might change next week. The attack surface might change next week. So the new or delta attack surface has to be tested, should be tested in order to to find if there is any new vulnerability. So these are the three challenges which probably I see in this in the current practice, and as we discussed before, that our mean time to remediate is, I think, just few days, not weeks. And if we increase that, then we are at the risk of being exploited. So there are possible recommendations, I think I'll suggest. One is combining threat intel and pen testing, and then doing it on a regular basis and ideally on a daily basis, which means that as and when threat intel gives intel on different threats, different CVEs being published, and so on, there is a pen testing practice, either internal or external or both, that consume the threat intel feed and goes and do the pen testing very specific using the threat intel. Now there are few organizations I've seen who has this practice implemented, but of course they are facing a challenge of scalability, how to scale this on a regular basis and on whole attack surface. Second probably recommendation is to combine your ASM attack surface management solution that you already have with threat intel with vulnerability management. So take the attack surface, combine it with threat intel, and then fine tune your vulnerability management to scan only those vulnerabilities which those targets and vulnerabilities, which combine them and scan for the prioritized vulnerabilities, right? Now this is probably is doable to a good extent, because vulnerability scanners probably can scale the threat intel. You can integrate, I think, in buy threat intel, and there are already ASM solutions in place, right? So yeah, doable. But then the challenge probably will be the integrating these three together. I've seen few organizations who have done this, but they are facing some challenges. The third solution probably is from FireCompass. We have something called day one CVE and threat exposure alerts. Now, how this works is very interesting. That and by the way, this also can be done by other solutions. We can go and implement it using open source tools. And if you want to know more on this, I think you can shoot me an email. We can discuss on this. So how this works like this, that FireCompass day one exposure alert, that first I think one of the main idea behind this is that we have realized that we need to use the same set of tools and techniques as the attackers are using against organizations, right? So as I discussed before, the automation workflow that attackers have implemented, I think we have to use the same workflow, and it has to be faster than, of course, attackers, so that we can detect this exposure and of vulnerabilities and threats before attackers can find out, and we can mitigate them. Now the advantage that organization have is that they have to just focus on their attack surface. On the other hand, attackers have to scan the whole internet. So it gives us some chance, some more lead time to go and act, right? Now what happens that in this approach is that we go and do a recon. So it works in 3 steps: do a recon, send exposure alerts, and then mitigate. Okay, so in recon, go and discover your attack surface, which include IPs, domains, subdomains, application technologies, and crawl the, crawl the applications and do a banner grabbing and index it for future research, and then analyze threat intel feeds on a daily basis, on a continuous basis, and then write signatures so that we can detect potentially expose attack tar assets in your attack surface in probably near real time. And then once, right, so this is the first step, which is recon. And then when a critical vulnerability being detected, being sent by threat intel team, threat intel feeds, then identify this exposure, and this should happen pretty fast, by the way. This should, within day one, we should be able to identify the exposure, and we should be able to send alerts to the respective other teams, so that they can act, they can be on their toes to monitor, so that they can configure their SOC. They can also configure certain security controls. They can configure their firewalls so that they can go and stop the attack at the right time, right? So once the alert is sent, the third step will be to mitigate or patch, and or probably the mitigation can also include implementing security security controls, which may not include a patch because the patch may not be available right away. So many of these alerts actually are generated even before, even the vulnerability scanners may not have the signatures to scan these vulnerabilities, right? And there may not be a patch available. And even if the patch is available, it may not be able to possible the system, patch the system. So you can go and place some other compensatory security controls, which include configuring your firewall so that you can make the life of attacker harder. And then next step will be to safely validate your security control, which means go and validate if the exposure is really can be exploited. I think so. This is what FireCompass Day 1 exposure alerts means. Now, okay, let me just summarize. I think we have reached the end of the present webinar. So let me summarize what we have seen. We have discussed the ransomwares, and they are on a rise, 20% per year, which means they are doubling every 3 years. The mean time to remediate has decreased from weeks to days because ransomwares are using automation and AI to scan the whole internet, to crawl technologies, and to detect CVEs and exploit them using automation. We have also discussed various latest threat actors and ransomwares and their respective CVEs that they are targeting. Around 6 CVEs we have discussed, which are being targeted few weeks back, up to few weeks back, and fixing those can reduce the risk of ransomware by at least 26%, assuming we have fixed all the before other CVEs and other things which have been targeted in the past. Then we discussed, what are the challenges in current practices to achieve mean time to remediate to one, within few days. And then we came to few recommendations by combining your current existing practices such as ASM, vulnerability management, and pen testing and threat intel to identify these critical CVEs, exposure of your attack surface. And then we have also, proposed, we have also described FireCompass Day 1 exposure alerts, which will allow you to get alerts within a day of your attack surface exposure to some of these ransomware CVEs so that you can act. I think with this, I'll open for any questions if you have any. And then,
Thank you so much, JC. So we have one question I have shared in the chat box. That.
Yes.
And meanwhile, I would request everyone in the audience, if you have any question, please post it and the speaker will address that question. And if you want to ask directly the question to the speaker, you can raise your hand and I will unmute you.
So may I know, so the question is, may I know the list of CVs associated with ransomware initial access? I think, yes, in this presentation, I have shared the 6 CVEs which are targeted. I think this presentation probably, I think 15 days back, up to 15 days back. That if you want latest, then we can share you, you can shoot us an email. We will share you the latest CVs which we have prioritized, or check out our blogs. We will publish another blog on on various CVs that we prioritize on regular basis. By the way, you can get these CVEs and a lot of more details on our blog. You can go to our FireCompass website and go to resources and blogs. You will get a regular feed of prioritized CVs from our research team. Yep.
So do we have more questions coming up from the audience side? If you have any questions, please feel free to ask.
Or shoot us an email. I think my email address is yeah.
So we have one more question.
Yep.
Yes, it's there in the chat box.
Okay, sure. So my email address is jitendra.chauhan@firecompass.com. If you have more questions, please shoot me an email. I'll try my best to reply.
So I'm
what
sharing.
is the best antivirus to protect from ransomware? This is very interesting. Now, the first thing we have to discuss is that initial foothold actually can also happen on servers which you may not install antiviruses, which may be devices, Linux devices, which probably have, which may not have antiviruses installed. Okay. But then there are many better versions available, like Kaspersky, I think we used to use. Microsoft Defender, I think, is doing pretty well. Then there are various, XDR solutions available. But these all antiviruses and XDR solutions, I think, works after initial foothold. And what we have covered is how to reduce, how to even mitigate the chance of getting initial foothold, right? So that's how it is. I think Microsoft Defender and is probably pretty good. McAfee, Microsoft Defender. I think all of them has a similar probably capability. But then a lot of attacks happens where they have specifically craft exploit to bypass these antiviruses. Yep. Okay. Any other questions?
So right now we don't have. So if anyone is having any more questions, please, we have shared the email address of the speaker. You can directly send your questions and get the answer for it.
Yep. Okay. Thank you very much. Yep. Have a great day.
Thank you for joining us. Thank you everyone in the audience for joining us today. And thank you, Jitendra, for such a wonderful session.
Thank you. Thank you. Very nice. Bye-bye.
Bye. Have a great day, everyone.